Hello students, welcome back to chemistry class. Today, let us continue the lesson carbon and its compounds. In the previous class, we have studied an important carbon compound ethanol. We have discussed its properties, its reactions. In the reaction, we have learned how does it react with sodium and how it reacts to give an unsaturated hydrocarbon. And we learn how do alcohols affect living beings and also alcohol as a fuel. Today we are going to learn about another important carbon compound, ethanoic acid. Let us see its properties. Ethanoic acid is commonly called acetic acid and it belongs to the group of organic acids called carboxylic acid. You know, the functional group of carboxylic acid is COOH and the molecular formula of ethanoic acid is CH3COOH. Have you heard the name acetic acid anywhere? Yes, it is present in vinegar. For what we are using vinegar? We are using vinegar as a preservative in pickles. So this 5 to 8% solution of acetic acid in water is called vinegar and it is used as a preservative in pickles. The melting point of pure ethanoic acid is 290 Kelvin. 290 Kelvin means how much degree Celsius it is? You know how to convert Kelvin into degree Celsius? 290 minus 273, that is 17 degrees Celsius. Say low temperature. So in this low temperature, what will happen? In cold climates, it freezes during winter. So it got another name, glacial acetic acid. So we have seen here the ethanoic acid common name is acetic acid. 5 to 8% of solution of ethanoic acid in water is called vinegar. Ethanoic acid or acetic acid in water is called vinegar. And why is it called glacial acetic acid? Because its melting point is 290 Kelvin and it freezes during winter in cold climate. So it got the name glacial acetic acid. The group of organic compounds called carboxylic acids. So as the name indicates, it is having acidic nature. But it is a weak acid compared to the mineral acids. What are the mineral acids? Hydrochloric acid, sulfuric acid, nitric acid, all these are mineral acids. They are strong acids. Compared to them, these organic acids are weak acids. What is meant by a strong acid and weak acid? Strong acids are those which ionizes completely. For example, HCl when dissolved in water, it ionizes completely. Almost all the molecules of HCl ionizes to form H plus and Cl minus ions. Such acids are called strong acids. Why these carboxylic acids or organic acids are called weak acids? Because ionization only partial. For example, in ethanoic acid, all the molecules do not undergo ionization. Only a few molecules undergo ionization, a few as molecule itself they are existing. So as a partial ionization takes place here, they are weak acids. Now let us see the reactions of ethanoic acid. In this lesson, we are going to learn three important reactions of ethanoic acid. One is esterification reaction, another one reaction with a base, one more reaction with carbonates and hydrogen carbonates. Let us see the first reaction, esterification reaction. So this video shows how the esterification is done.
Do you know how to prepare ester? Let's study the process of formation of ester. Here we have used ethanol, glacial acetic acid and concentrated sulfuric acid. Take a test tube containing a mixture of 1 ml ethanol, 1 ml glacial acetic acid and a few drops of concentrated sulfuric acid and warm it in a water bath for few minutes. After some time, pour that heated mixture into a beaker containing 20 to 50 ml of water. This will give you a sweet smell. Hence, the resulting mixture is an ester.
So here we have seen what is reacting here, ethanol and ethanoic acid. What we are getting as a product, ester. So let us see what is an esterification reaction. Esters are commonly formed by the reaction of an acid and an alcohol. Let us see the equation. You know, a carboxylic acid will have a COOH functional group, C double bond O, single bond OH. What is this R indicate? It can be bonded to any alkyl group. Already in the previous class you have seen what are alkyl groups. Methyl, ethyl, propyl, etc. If it is methyl, it is CH3. Ethyl means this R is C2H5, propyl, etc. So this is a general representation of a carboxylic acid. An alkyl group, it is bonded to a COOH group. This is general representation of an alcohol. You know the functional group of alcohol is OH. So one alkyl group is attached to an OH group, CH3OH, C2H5OH, etc. So here to understand this reaction better, this R alcohol, it is reverse way the formula is written. R dash OH. Why R dash is written? This alkyl group and this alkyl group may be different also. It can be same also, it can be different also. To show that difference only here R dash is given. So R dash OH. To understand the reaction better, it is written in the reverse order. R dash OH. So what is happening during this reaction? This OH and H is eliminating as water. So we are getting, so here is bond is formed between the C and O. So what product we are getting? R, C double bond O. The C is attached to this O, R dash. R, C, O, O, R dash. Plus this H and OH is eliminated as water. So here we are getting carboxylic acid react with alcohol to form ester and water. So let us see the example with ethanoic acid. This ethanoic acid, here carboxylic acid, this R is CH3 means that is the ethanoic acid, CH3COOH. Reacts with absolute ethanol. Ethanol means this R dash will be C2H5. C2H5 or CH3CH2. C2H5 we can write it as CH3CH2 also. So how does the reaction takes place? Let us see. So here this equation shows the reaction between ethanoic acid and ethanol. So carboxylic acid in the place of R, this is CH3 means CH3COOH. This is the ethanoic acid. It's react with, in the place of this R dash, if it is C2H5 or CH3CH2, this is ethanol. So here ethanol and ethanoic acid react to form the ester and water. So here ethanol OH from the ethanoic acid and H from ethanol is eliminated as water. Always when carboxylic acid and alcohol reacts, OH is removed from the carboxylic acid and H is removed from the water. H is removed from the alcohol to form the water. So here this OH and H are removed as water, HOH, that means water. And here this carbon is attached to this oxygen. So what product will get? CH3CO, the C is attached to this O, CH2, CH3. So CH3CO, O, CH2, CH3. You can see here CH3CO, O, CH2, CH3. This is an ester. So how to name the ester you are not learning in 10th standard, that in higher classes you will learn. So just understand an ester is formed. So what is meant by esterification reaction? Reaction of an Now, generally, these esters are sweet smelling substances. So, it is used in making perfumes and as a flavoring agents. The food items as a flavoring agents it is used. You might have used the squashes, fruit juices, etc., having different flavors, mango flavor, orange flavor, etc. So the original fruit will not be added there, even though we are getting the smell and taste of these fruits because of the presence of these esters. On treating with sodium hydroxide, which is an alkali, the ester is converted back to alcohol and sodium salt of carboxylic acid. You might have seen here this esterification reaction. It is a reversible reaction. So you can see here double arrow mark. That means forward direction and backward direction the reaction takes place. Acid and alcohol react to form ester and water. Ester when react with water, in turn we are getting acid and alcohol back. Okay, so let us see here on treating this ester with sodium hydroxide, that is an alkali, we are getting the ester is converted to alcohol and sodium salt of carboxylic acid. This reaction is known as saponification because it is used in the preparation of soap. The sodium salt of carboxylic acid is the soap. Chemically, it is soap. Soaps are sodium or potassium salts of long chain carboxylic acid. If you are using potassium hydroxide in the place of sodium hydroxide, we are getting potassium salt of carboxylic acid. If sodium hydroxide is used, we are getting sodium salt of carboxylic acid. Alkali means it is a base. So here we know alcohol and acids, carboxylic acid, when they react, we are getting ester and water. Ester, if it is reacting with a base like sodium hydroxide or potassium hydroxide, what are the products we are getting? We are getting sodium salt of carboxylic acid and the alcohol. The sodium or potassium salt of carboxylic acids are called soap. So this reaction is used in the manufacture of soap. So that is the reason this reaction is called saponification reaction. So what is saponification reaction? An ester when reacts with an alkali like sodium hydroxide or potassium hydroxide, we are getting sodium or potassium salt of the carboxylic acid and the alcohol. This reaction is called saponification reaction. Why is it called saponification reaction? Because it is used in the manufacture of soap. Because soap is sodium or potassium salt of long chain carboxylic acid. Let us see the general equation. We know how to write the ester formula, general representation of an ester. This is the functional group of ester, C double bond O, single bond O. So here one alkyl group is attached, here one alkyl group is attached. R1 COO R2, or we can write R and R dash, R1 R2, anything. Here instead of R and R dash we have written R1 and R2. So R1 C double bond O R2. R1 COO R2. This is a general representation of an ester. So when it is reacting with an alkali or sodium hydroxide, what is happening here? Here the bond breaks. You have seen already esterification means OH from the acid and H from the alcohol is eliminated as water. So here the bond breaks and here ONA is attached here and H is attached here. So what products we are getting? RCOONA and R2OH. RCOONA plus R2OH. What is this RCOONA? That is a sodium salt of carboxylic acid. You know RCOOH means carboxylic acid. In the hydrogen place one sodium occupies here. That is called the sodium salt of carboxylic acid. What is R2OH? That is an alcohol. You know alcohol functional group is OH. This is the general representation. If you are using here CH3 and here CH3CH2, this is ethyl acetate. So here if it is CH3 and this R2 is CH3CH2, it is ethyl acetate. When it reacts with sodium hydroxide, here the bond breaks and Here ONA is attached, here H is attached. So we are getting CH3COONA plus CH3CH2OH. H is attached. Here the bond breaks. Here there is a bond between carbon and oxygen. That bond breaks here. Here H is attached and here ONA is attached. So we are getting the product CH3COONA plus CH3CH2OH. You know, this is sodium acetate, sodium salt of acetic acid or ethanoic acid. It is called sodium acetate or sodium ethanoate. Common name is sodium acetate. It is also called sodium ethanoate. Ethanoic acid, sodium salt. And this you know, that is ethanol. So ethyl acetate, that is an ester. When it is reacting with sodium hydroxide, we are getting sodium acetate. That means sodium salt of a carboxylic acid and ethanol or ethyl alcohol. So we have seen now this reaction between ester and an alkali. We are getting sodium salt of the acid and alcohol. The sodium salt of the acid is called soap. So this reaction is called saponification reaction because it is used in the preparation of soap. Next, let us see another reaction, how the ethanoic acid react with a base. For example, as a base we have taken here sodium hydroxide. So how it is reacting with a base? Like mineral acids like hydrochloric acid, sulfuric acid, nitric acid, etc. Ethanoic acid also react with a base like sodium hydroxide. So what are the products we are getting? We are getting a salt and water. Here, what is the salt here? Sodium ethanoate or sodium acetate. This is the equation. Acetic acid or ethanoic acid CH3COOH reacts with sodium hydroxide. We are getting CH3COONA, sodium salt of ethanoic acid or sodium ethanoate plus water. Ethanoic acid react with sodium hydroxide to form sodium ethanoate and water. So generally what we can say, an acid reacts with the base. We are getting its sodium, salt and water. So here ethanoic acid react with a base or alkali, sodium hydroxide. We are getting sodium salt of the acid and water. What is the sodium salt? In the place of hydrogen, one sodium occupy. That is called the sodium salt. And we are getting water as the byproduct. This is called sodium ethanoate, otherwise sodium acetate. Next, how does ethanoic acid react with carbonates and hydrogen carbonates? Let us see an activity. Here is the arrangement of apparatus used in this reaction. So a test tube is taken. It is connected with a thistle funnel and there is a delivery tube and there is a test tube which have lime water. So how we are conducting this experiment? Let us see. So take a spatula full of sodium carbonate in a test tube and add 2 ml of dilute ethanoic acid. So in the test tube what we have taken? We have taken sodium carbonate. What we have added to this? We are adding through the thistle funnel, we are adding ethanoic acid, dilute ethanoic acid. And now the reaction takes place. What can we observe? We can observe that a gas is released in this reaction mixture. A gas is released. Now, pass this gas produced through freshly prepared lime water. So here already another test we have prepared lime water. Lime water means calcium hydroxide solution. Through this lime water, this gas we are passing. What we can observe? We can observe that this lime water turns milky. What does it indicate? Any gas is passing through lime water. If lime water is turning milky means the gas produced is carbon dioxide. So here the lime water turns milky. It shows that the gas produced is carbon dioxide. So how the experiment is done? In a test tube we have taken sodium carbonate. To that we have added dilute ethanoic acid. The reaction takes place. A gas is produced. The gas is passed through lime water, freshly prepared lime water. Lime water means So when the gas is passed through lime water, we can see that lime water turns milky. It indicates that the gas produced is carbon dioxide. So next reaction. So we have seen now the reaction of ethanoic acid with sodium carbonate. The same way, in the place of sodium carbonate, we can take sodium hydrogen carbonate and do the experiment the same way. We'll get the same result. So let us see the reaction and the equation how we can write. So ethanoic acid reacts with, we have seen now, ethanoic acid reacts with carbonates and hydrogen carbonates to give rise to salt, carbon dioxide and water. The salt produced is commonly called sodium acetate, or it is also called sodium ethanoate. So this is the equation. This is a balanced equation. 2CH3COOH, that is ethanoic acid, reacts with sodium carbonate Na2CO3. We are getting CH3COONA, 2CH3COONA, that is sodium acetate, or it is also called sodium ethanoate, plus water and carbon dioxide. So ethanoic acid reacts with sodium carbonate. What are the products we are getting? We are getting sodium salt of ethanoic acid, that is sodium acetate or sodium ethanoate, and water and carbon dioxide. So that means salt, water and carbon dioxide. Here the salt's name is sodium acetate or sodium ethanoate. Same products we are getting if you are using sodium hydrogen carbonate also. The equation is CH3COOH. This is ethanoic acid. When it is reacting with sodium hydrogen carbonate, that is NaHCO3, we are getting CH3COONA, that means sodium acetate or sodium ethanoate, plus water and carbon dioxide. So all these reactions are summarized in this video.
Ethanoic acid. In this module, you will learn about ethanoic acid and its properties. You may have observed your mother using vinegar while making pickle or cooking noodles for you. Well, vinegar adds tanginess to the food items and also acts as a preservative. Vinegar has a carbon compound as one of its main constituent, which is responsible for its tangy taste. This carbon compound is the carboxylic acid called ethanoic acid. Actually, vinegar is the 5 to 8% solution of ethanoic acid in water. So, let us study about this carbon compound, ethanoic acid, in detail. The molecular formula of ethanoic acid is CH3COOH. It consists of a carbon atom that is attached to 3 hydrogen atoms and 1 carboxylic acid functional group. Let us now check some important physical properties of ethanoic acid. It has a sour taste and a pungent smell. It is highly soluble in water. All these properties we have already seen while discussing about vinegar. Another important physical property is its melting point, which is 290 Kelvin. Due to its low melting point, it freezes during winters, and so its other name is glacial acetic acid. Let us now move to the chemical properties of ethanoic acid. For this, let us do some experiments. Shown here is a test tube having 1 milliliter of ethanoic acid. To this, let us add an equal amount of ethanol and a few drops of concentrated sulfuric acid. Now, let's warm this mixture in a water bath. Next, let's add the resultant mixture to the beaker containing 20 to 30 milliliters of water. On doing so, we get a fruity smell. This fruity smell is produced because of the chemical reaction of ethanoic acid. In the presence of concentrated sulfuric acid, the hydrogen of the alcohol and the hydroxyl from the carboxylic acid are lost that together form a water molecule. The remaining part of the two compounds bond together, giving rise to a new carbon compound, ethyl ethanoate. This carbon compound is an ester and has a fruity smell. Because of the fruity smell of the esters, these are often used in the manufacture of perfumes. This reaction of alcohol with carboxylic acid forming an ester is known as an esterification reaction. Interestingly, we can convert the ester back to alcohol and acid. This can be done by adding an alkali, sodium hydroxide, to the ester, ethyl acetate. Sodium hydroxide reacts with ethyl ethanoate, forming sodium acetate, that is, the sodium salt of ethanoic acid and ethanol. This reverse reaction of esterification reaction is used in the synthesis of soaps. So, this reverse reaction is called the saponification reaction. In a saponification reaction, one of the products is the sodium salt of the carboxylic acid. Such sodium salts can also be formed by the direct reaction between an ethanoic acid and the alkali sodium hydroxide. During this reaction, the sodium salt is formed along with water. This acidic nature can also be confirmed by the litmus paper test. Its solution turns the blue litmus paper red. However, it is not a very strong acid as mineral acids like hydrochloric acid. It is so because not all the molecules of ethanoic acid remain ionized in the solution. In contrast, in the aqueous solution of hydrochloric acid, all the molecules remain ionized. The acidic nature of ethanoic acid is further responsible for some of its chemical reactions. Let's check out one such reaction. Shown here is sodium carbonate in a test tube. To this, let us add a dilute solution of ethanoic acid. A gas is released, which is then allowed to pass through the freshly prepared lime water. As we can observe, the lime water turns milky. It happens because ethanoic acid reacts with sodium carbonate to form sodium ethanoate, water, and carbon dioxide. The gas released is carbon dioxide that turns the lime water milky. Let's recap. Vinegar is 5 to 8% solution of ethanoic acid in water. The molecular formula of ethanoic acid is CH3COOH. Ethanoic acid has a sour taste, pungent smell and low melting point of 290 Kelvin. Ethanoic acid is soluble in water. Its solution is weakly acidic. Ethanoic acid forms ethyl ethanoate, an ester, on reacting with ethanol in the presence of sulfuric acid. The reaction is called esterification. Saponification is the reverse reaction of esterification, in which ethyl ethanoate reacts with sodium hydroxide to form sodium ethanoate and ethanol.
So today we have learned the topics: properties of ethanoic acid, reactions of ethanoic acid. Among the reaction we have studied esterification, reaction with a base, and reaction with carbonates and hydrogen carbonates. What is esterification? Reaction of alcohol and an acid in the presence of an acid catalyst to form ester and water, that is called esterification reaction. What is saponification? It is a reverse reaction of esterification. When an ester is reacting with an alkali like sodium hydroxide, we are getting sodium salt of the carboxylic acid and alcohol. The sodium salt of carboxylic acid is the soap. So this reaction is used in the manufacture of soap. This reaction is called saponification reaction. Then we learn how does ethanoic acid react with a base like sodium hydroxide. What are the products we are getting? We are getting salt and water. The salt name is sodium ethanoate or sodium acetate. Then we learn how does ethanoic acid react with carbonates and hydrogen carbonates. So how ethanoic acid react with sodium carbonate and sodium hydrogen carbonates. In both these reactions, we are getting the product salt, water and carbon dioxide. Here also salt is sodium ethanoate or sodium acetate. Hope you understood today's class. Thank you, children.